Hello everyone. So today we will discuss about the types of supports and the supports commonly being used in the civil engineering or in basic of engineering. So before that, please, if you haven't subscribed my YouTube channel, please do subscribe the YouTube channel. And if you like the video, please press the like icon, and also please press the bell icon to get the latest updates about the videos. Okay, so continue with the types of supports. So there are three commonly used types of supports. Although there could be many other types of supports. And I will draw them in a tabulated form so that we can uh, we can differentiate between the supports types and its functioning. All right. Supports and symbol and the reactions a support can take. Now the first commonly used type of support is roller support. And the symbol for roller type of support is like this in engineering, or some people commonly use like this. And another type of support is hinge support, and the symbol for the hinge type of support is like this, or some people use it like this. Now the third type of support is fixed support, and the symbol for a fixed type of support is like this. Alright, so we will discuss about the first type of support, which is roller support, and what does it do. But before heading to the roller type of support, you may know that for for an object to be in equilibrium in a two-dimensional system, it should it should it should accomplish this equilibrium equation. Like the first equation is the summation of all forces along that system should in the y direction should be equals to 0. Summation of all forces and the x direction along that system will be equals to 0. So remember, we are talking about the two-dimensional system. And the third equilibrium equation is that summation of all moment creating in that object because of the applied loads or reaction should be also equals to 0. Alright, now heading back to the roller support. What does a roller support do? That if we apply a load on this support, say like this load of any force, so the support is able to resist that load only in the vertical direction. So this is the applied reaction R. Okay, so this load can resist that reaction, but if we apply a load in the horizontal direction, a load or force in the horizontal direction, the support is not able to support that reaction or load. So there is no supporting of horizontal loads or forces in the horizontal direction in case of roller support. So what will happen, that this roller support will move. It will move and the direction of the applied load. Okay, when the load is applied in this direction, it will be able to move in this direction. So, to summarize, the roller support can only resist vertical loads and forces. So, the reaction capacity of a roller support is only in the y direction, in the vertical direction or the y direction. If we are assuming the system x in this direction and y in this direction. Alright. Now the second type is the hinge support. Now what does the hinge support do? If you apply a load in the vertical direction, our forces or loads in the horizontal and vertical direction, the support is able to resist both horizontal and vertical forces or reactions, horizontal and vertical. Alright, this R just represents the reaction. Horizontal means the horizontal reaction, but the support is not able to resist any movement. So suppose if there is a movement, because of any applied load or reaction, so this support is not able to resist any movement. Alright, and so is the case in the roller support, that if a moment is applied, the support is not able to resist any movements. Alright, so finally we now know that the hinge support can resist the vertical loads and forces and the horizontal loads and forces. Now the third type is the fixed support. Now what does a fixed support can do? I mean, what does a fixed support can resist? So if we have three applied loads, a vertical load, a horizontal load, and a moment M. So the fixed support is able to resist the horizontal load, the vertical load, and the moment. Alright, so horizontal and vertical and moment. So if there is a vertical load, the fixed support is able to resist it. If there is a horizontal load, the fixed support is able to resist it. If there is a movement because of the applied loads or reactions, the fixed support is able to resist those moments. So you know that the fixed support can resist the vertical loads, the horizontal loads, and the applied moments. So these are the three equilibrium equations for a two-dimensional system, which for a body to be in equilibrium should satisfy these equations. Alright, thank you so much for watching the video.